Kia ora koutou. This video is for Nikhil, and this is from the 2014 November stats paper, paper 73. It's one that at first can look quite daunting, but once you get the hang of these types of problems, they're really, really easy as long as you set them up well and you always think about whether I'm looking at the sum of separate random variables or a linear combination of random variables. So I'm just going to work through it now. We've got two kinds of tomato, A and B. Tomato A is normally distributed with a mean of 125 and a variance of 900, and tomato B has got a mean of 130 and a variance of whatever 32 squared is. So first we have to work with the total mass of 4 randomly chosen tomatoes of type A and 6 randomly chosen tomatoes of type B. And we have to find the probability that that total is less than 1.5 kilograms. So I'm going to set up a new variable which is called T. And T is made up of 4 different tomatoes of type A. Think of them as A1 plus A2 plus A3 plus A4. And now we've got 6 type B tomatoes. Probably the most common mistake that students make here is instead of writing this, they go a bit too fast and they go, oh yeah, I've got 4 type A tomatoes, and they write down 4A. And that's going to lead us to, well, not a disaster, but a bit of a problem. Because when you see this, this is a linear combination, okay? It's not the same thing as the sum of 4 different random variables. So in this case, we've got 10 random variables and we're adding them together. And if you go all the way back to, I think it was in chapter 9 or 10, we learnt about how when we've got 2 variables, suppose that we've got x plus y, then the expected value of x plus y is equal to the expected value of x plus the expected value of y, right? And the variance of x plus y, if those variables are independent, is equal to the variance of x plus the variance of y. So what we've got here is an extension of that where we've got 4 here and 6 more here. So we can find the expected value of the total weight, and it will be the expected value of tomato 1 plus the expected value of tomato 2 and so on. So working through that, we've got one lot of, what was the average for A? It was 125 grams. So we've got 125 plus 125 4 times, and then we've got 6 tomatoes of type B, so we're going to have plus 130, plus 130, plus 130. So of course that's 4 times 125 and 6 times 130, right? Where the problem arises is in the variance, right? So if I've got the variance of x plus y, I can add up the 2 separate variances, assuming, let's just turn off ink to shape, assuming that x and y are independent, okay? So assuming independence. But if instead I've got a linear combination, which is the variance of, say, 6x, the variance of that is 6 squared, so 36 times the variance of x. Right, we're going to need that in the second part of the question. We don't need it yet. So coming back to this one, where have we got to? Well, we've got our total, which is the total mass of 10 different tomatoes. And because we know that these are both shaped as normal curves, that means that the total is also going to have the shape of a normal curve, right? And so the average is going to equal 1,280, and the variance of the total is going to be the variance of the first tomato and the variance of the second tomato, and so on until we're finished with the 6th of the B tomatoes. So adding up those variances, we've got 4 lots of that variance, which is 4 times 30 squared, and then we've got 6 of these, so 6 times 32 squared, and putting that together we get 9,744. So now we're good to go, because what we're trying to figure out here is the probability, sorry about the jumping screen, guys, I don't know what's going on there. Find the probability that the total mass is less than 1.5 kilograms. Just notice that we're working in grams, so we're going to turn 1.5 kilograms into 1,500 grams. We want to find the probability that the total is less than 1500. And this is now back to an AS problem. We're just going to standardize. So here's my picture of T. So T less than 1500 looks like that. So that's equal to the probability that Z is less than 1500. Subtract off the mean of 1280 and divide by the standard deviation, which is 9744. That gives me the probability that Z is less than 2.287. And we go to our tables, and this is the Z value that we're looking for. I got 0.9889, which to three significant figures gave me 0.989. Now the marking schedule gave me a tiny different number. I'm not sure how, but this is how I did it here. Right, so here's our table, and we're just hunting through there for 2.2. Where's 2.28? 2.28. No, it's this one here, 2.287, and I did a little add factor because of the 7, so we added on that. Okay, so that actually wasn't the part of the question that Nikhil wanted done, but I've done the whole lot. The second part is one where we're going to have to set up a new random variable. Now the second part looks really full on, but it's all right. Find the probability that a randomly chosen tomato of type A has got a mass that is at least 90% of the mass of a randomly chosen tomato of type B, right? You can do this on your next trip to Pack and Save if you can afford to buy tomatoes. All right, what we want to find is a linear combination. But the way to work with these is to say, well, we want to know when is A, the weight of A, greater than or equal to 0.9B. And A has got some normal distribution, and 0.9 of B has got some other normal distribution. We're going to combine those like this. So if A is greater than or equal to 0.9B, we want to have A minus 0.9B being greater than or equal to 0. So this is my new random variable. What do we know about the expected value of A minus 0.9B? That's going to be E of A minus 0.9 E of B, using my linear combination rules. That gives me 125 minus 0.9 times 130, and that gets me 8 grams. Now the variance is the next thing we've got to work out, because once we've done that, we know that we've got a normal distribution, so we can do our usual standardizing thing. So this time we're using the linear combination rules. This is going to equal the variance of A plus 0.9 squared, which is 0.81, times the variance of B. Right, so the rule that I'm using here, if you need to revise it, is this one. That if I've got the variance of AX, let's do minus BY, that's going to equal A squared var X plus, I'll do that as a plus B squared var Y. If we now make this -1, we'll see that we get the result that we looked at in class. We get A squared var X plus -B squared var Y. So that's why, even though we've got in here, we've got a minus sign, here we've got a plus sign. So just watch out for that. All right, so now we've got to chuck some numbers in there, and we're going to get the variance. Variance of my linear combination is going to be 30 squared plus 0.81 times 32 squared, which is equal to 1,729.44. Now let's go back to what we were looking for. This is the probability that we wanted to find, but we rewrote it into this form here. Okay, so what we're asking is, when is the weight of A, take away 90% of the weight of B, positive? And we found that the average of that is 8 grams. So we can draw this out. This variable is A minus 0.9B, and on average it's 8 grams. We want to figure out when is, so we want to find the probability that A minus 0.9B is greater than or equal to 0. So this is the probability that we're after. And that's really easy to do now. We're just standardizing. So we're going to take off the mean, which is 8, and we're going to divide by the standard deviation, which is the square root of the variance. So we get this, and then we get the probability that Z is greater than negative 0.1924, which fits with my picture. So here's my Z picture. If I want this area here, negative 0.1924, that is the same as phi of 0.1924. All right, so just using the symmetry of the graph, here's what I get here. There's 0.1924. I'm going to work backwards like that. Okay, and then we get 0.5769 for our final answer. Okay, I think with these, the best way to get better at them is to do quite a few of them. I've videoed some already. I'll pop some links for the other ones that are in the same category of problem onto Google Classroom. Nikhil, I hope this helped. If you could let me know if this is making sense now in an email, that would be really good. Thanks for watching and keep on sending in your questions. I'll do some more tomorrow.